Good evening, everyone. My name is Christopher Richards, and I am a software engineer at Q&A. Today, I will be presenting on cloud development, focusing on the transition from a desktop application to a cloud-based environment, and how this shift can enhance our application scalability and efficiency. The purpose of this presentation is to articulate the intricacies of cloud development to both technical and non-technical audiences. We will cover the following topics: containerization and how it aids in migrating a full stack application to the cloud, the benefits of Docker Compose for orchestration, the advantages of serverless architecture, the principles of cloud-based development, and methods for securing a cloud application. Finally, I will summarize the key takeaways. First, let's talk about containerization. Containerization involves packaging an application and its dependencies into a container, allowing it to run consistently across different environments. We use two models for migrating applications to the cloud: lift and shift, which involves moving applications with minimal changes, and refactor, which modifies applications to better suit the cloud environment. The necessary tools for containerization include Docker for creating containers, Kubernetes for managing and orchestrating these containers, and CI/CD tools like Jenkins and GitLab CI for automating the deployment process. Next, we have orchestration. Orchestration involves managing the lifecycle of containerized applications. Docker Compose is a valuable tool in this process. It simplifies defining and running multi-container Docker applications using a YAML file. This tool facilitates starting, stopping, and rebuilding services, and enhances collaboration by allowing versioning and sharing of configurations. Moving on to the serverless cloud, serverless refers to a cloud-native development model that allows building and running applications without managing servers. This model offers automatic scaling, a pay-per-use billing model, and reduced operational complexity. For storage, AWS S3 provides scalable object storage with virtually unlimited scalability, high durability, and global access, compared to local storage, which is limited by physical hardware and accessibility. Serverless APIs offer several advantages, including automatic scaling and cost efficiency, as you pay only for the compute time used. AWS Lambda allows running code in response to events without managing servers. Scripts produced for this include Lambda function code in Node.js or Python and API gateway configuration scripts. To integrate the front end with the back end, we developed a front end with API calls to Lambda, configure API gateway to route requests to Lambda functions, and secure the API endpoints with IAM roles and policies. When it comes to databases, we compare MongoDB and DynamoDB. MongoDB is a document-oriented NoSQL database with a flexible schema, while DynamoDB is a key-value and document database that is fully managed and supports single-digit millisecond performance. We perform basic CRUD operations and complex queries using DynamoDB streams and MongoDB aggregation. The scripts produced include Lambda functions for data manipulation, CloudFormation templates for DynamoDB table setup, and MongoDB setup scripts. Cloud-based development principles include elasticity and the pay-for-use model. Elasticity is the ability of a cloud service to dynamically allocate resources based on demand, ensuring efficient use of resources and cost management. The pay-for-use model means billing is based on actual resource consumption, encouraging efficient usage and scalability. Securing your cloud application is crucial. For access control, we use IAM roles to manage permissions and implement multi-factor authentication. We restrict access based on the least privilege principle, regularly rotate credentials and access keys, use AWS IAM to define access controls, and monitor access logs with AWS CloudTrail. In terms of policies, we define roles and attach policies to them, use AWS managed policies for common tasks, create inline policies for specific access control, regularly review and update policies, implement policy versioning for tracking changes, and use policy conditions to enforce security requirements like IP address and time of day. Custom policies are tailored to specific application needs. For example, we create policies for accessing specific S3 buckets or DynamoDB tables. We use resource-based policies to control access to specific resources, combine multiple policies using policy variables, apply tags to resources for tag-based access control, and utilize service control policies in AWS organizations for centralized control. API security involves securing the connection between Lambda and API gateway with IAM roles and policies, enabling logging and monitoring with CloudWatch, using API keys to control access to API gateway endpoints, implementing usage plans to manage API usage and rate limits, enabling AWS WAF to protect APIs from common web exploits, and use mutual TLS for secure communication between clients and your API. For Lambda and database security, we use VPC and security groups to control access, encrypt data at rest and in transit, implement AWS KMS for managing encryption keys, configure VPS endpoints for secure access to AWS services, monitor and audit Lambda function logs with CloudWatch and CloudTrail, and use IAM roles to grant Lambda functions only the permissions they need to interact with the DynamoDB. Finally, for S3 bucket security, we use bucket policies and IAM roles, enable server-side encryption and access logging, implement versioning to protect against accidental data deletion, use S3 object lock to prevent object deletion for a specified retention period, set up S3 access points for simplified and secure access management, and utilize S3 block public access settings to ensure buckets and objects are not publicly accessible. In conclusion, containerization and orchestration simplify the deployment and scaling. Serverless architecture provides scalability and cost efficiency, and security is paramount in cloud applications, requiring robust policies and access controls. Thank you for your time, and I am happy to answer any questions that you may have.